So this is number 11 from the worksheet that says Kinematics Practice. It's one of the free fall problems. A high diver jumps straight up in the air at a velocity of 4 meters per second off of a 10-meter high platform. How long is the diver in the air before making a splash? And I forgot to add the question mark. So let's get that in. Oops. There we go. Okay. Struggles. Good. Okay. So the first thing we want to do is draw our diagram. You have your diving board. The diver is going to jump off the diving board, reach a maximum height, come briefly to rest at that maximum height, and then they will be diving down into the water. Had a little direction change there. What are we given? We know that the initial velocity is 4 meters per second. And we know that this is a positive velocity because the diver is jumping straight up. We also know that the platform is 10 meters high. So from here to the water would be my delta y. Because the diver is ending up lower than where they start from, delta y will be equal to negative 10 meters. Since the diver is in free fall, we also know the acceleration will be g. And what are we looking for? Time. We want to know how long the diver is in the air before making a splash. So let's see. Based on what we're given, we have the initial delta y and a. We're looking for time. There's two ways to solve this problem. I'm going to take the longer way just in case you ever get a similar problem where you have to break it up into two, but this can also be solved quadratically. So I'll do it the longer way first, and then I'll show you the quadratic way. If you don't care about the longer way, just fast forward to the end for the quadratic. So the longer way to solve this problem, you want to break it up into part 1 and part 2. Part 1 would be when the diver is just going up to the maximum height. Part 2 would be when they're going down. So for part 1, we know the V initial is 4 meters per second. As the diver reaches their highest point, they'll come to rest, so V final will be 0. And again, we know that the acceleration is g, so negative 9.8 meters per second squared. We'll be able to find out how high the diver goes and also how long it takes to get to that maximum height. Given V final, V initial, and A, looking for delta y, you don't have time, so let's use the no time equation. V final squared equals V initial squared plus 2A delta y. For the up only, my V final is 0, so that goes away. Isolating what I'm solving for, negative VI squared over 2A gives us delta y. So negative 4 meters per second squared over 2 times negative 9.8 meters per second squared equals delta y. The negatives will cancel out, so you'll end up with a positive delta y. This makes sense because you're going up, so the diver is ending up higher than where they started. Dividing this, we end up with 0.816, keeps on going, meters for delta y. And this is a number that you would want to store in your calculator. If the problem, it does not, but if the problem asked how high the person went, so what was their maximum height, we would just take this delta y and add it to the given 10 meters for a maximum height of 10.81 keeps on going. It's not asking for that, but if it did, that's how you would solve for maximum height. So we know how high the diver goes from the top of the diving board, and we need to see how long that takes. I have a choice here as to what equation I want to use. I'm just going to use V final equals V initial plus AT. again, either one would have worked since we have delta y. So v final is 0. V initial we don't have time. So negative v initial over a equals time, negative 4 meters per second divided by negative 9.8 meters per second squared, running out of room, equals your time. And this is just the time to go up. The two negatives cancel as they should. Time can't be negative. This gives us 0.408, keeps on going, seconds for your time. You also want to store this number in your calculator. So you should have two numbers stored because, again, you want the whole unrounded answer. If you forget where the store button is, it's above the on your graphing calculators. Both of these numbers should be stored as something, and just make a note. So say you wanted to store this as A and this is B. You don't have to, but whatever you want to store those as. So we have two things from part 1, how high they reach to go up and then how long it takes. Let's now look at part 2. If something goes up, unless it's landing on anything, it's going to have to come back down. So part 2 will be the down motion. What do we know for part 2? Well, we know that the object, in this case the diver, is starting from rest. So from up to down, v initial is 0. We also know what delta y is. I explained how you didn't have to find maximum height, it wasn't asking for it, but in this case you need to know your whole delta y from the diver's highest point down to 0. So your delta y would be negative 10.816, keeps on going, meters. Negative because the diver is ending up lower than where they started. We also know that acceleration, diver is still in free fall, is negative 9.8 meters per second squared, and we're looking for the time for this to happen. Given v initial, delta y, and a, it makes sense to use y equals 1/2 a t squared plus v initial t. Going down, v initial is 0. 2 delta y over a equals t squared. 2 times negative 9.8 meters, wrong one. 2 times negative 10.816 meters divided by negative 9.8 meters per second squared equals t squared. Once again, my negatives cancel out. You can't take the square root of a negative, so if you ended up with a negative value for t squared, you forgot a negative somewhere. This becomes 2.20, keeps on going. Seconds squared equals t squared. Square root of that is 1.48, keeps on going, seconds for your time. So we know how long it takes to go up. We know how long it takes to come back down. Now all we have to do is add those together. So your total time would equal the time from part 1 plus the time from part 2. So 0.408 keeps on going. You should have stored that number in your calculator. Plus 1.48 keeps on going, seconds, equals your total time. This comes out to 1.89, keeps on going, seconds. Problem only has one sig fig in the givens, so your total time from the time the diver leaves the diving board until they make a splash is about 2 seconds. This was the long way to solve the problem, and the reason I did that again was because if you're ever looking for maximum height, you're going to need to know how to do this in terms of part 1 and part 2. Solve it the short way using the quadratic formula. So our original givens, we have v initial, you have your acceleration, and you have your delta y. So you would want to use delta y equals 1/2 a t squared plus v initial t. Bringing the delta y over to the other side to set this equal to 0. 1/2 a t squared plus v initial t minus delta y equals 0. You have A, you have the initial, you have delta Y. 1/2 times negative 9.8 meters per second squared t squared plus 4 meters per second t minus a negative 10 meters equals 0. Half of negative 9.8 is negative 4.9 meters per second squared t squared plus 4 meters per second t minus a negative plus 10 equals 0. In your calculators, I gave you the quadratic formula program. Negative 4.9 would be your A, 4 would be your B, 10 would be your C. When we put this in, here are our two values. The two values your calculator gives you should be negative 1.077, keeps on going, and positive 1.89. So because time can't be negative, you know that the answer has to be the 1.893, keeps on going, seconds. This is exactly the same answer that we got solving it the other way. So time, again, is approximately 2 seconds. Two ways to solve, depending on what the problem would be asking for, would determine whether or not you have to break this apart into two. In this case, it could have been solved just using the quadratic formula. Again, if you're looking for maximum height ever, you're going to want to break it apart into part 1, part 2, so the up motion and the down motion, like I did in the longer way.